Hello everybody, Math Hobo here, and today we will be discussing the integrals of trigonometric functions which are integral to our understanding of Fourier series. So today we will discuss why integral 0 to 2 pi cosine of nx, or let's say mx, is equal to 0, and y is integral 0 to 2 pi of sine mx equals 0 for all m in integers such that m does not equal to 0. So what we're trying to prove is that the integral from 0 to 2 pi of the cosine and the sine function of mx, there's a dx here, dx is equal to 0 for all non-zero integers m. So we will prove the cosine case first. So the integral of cosine mx is 1 by m sine mx, and because it's a definite integral from 0 to 2 pi, we'll take this from 0 to 2 pi. So then we have this is equal to 1 by m into sine of m times 2 pi minus the sine of 0. And let's ask ourselves what this here is. Well, we have a non-zero integer multiplied by 2 pi, and we're trying to figure out the sine of that. And the sine wave looks like this, where this is 2 pi. So for every integer multiple of 2 pi, sine of x always equals 0. So we've established that this term equals 0, and we all know that sine of 0 most definitely equals 0. So this entire thing must equal 0, ergo the integral must equal 0. Now we proceed to the sine integral. So let us take integral 0 to 2 pi of the sine of mx dx. Now sine mx dx integral simply equals negative 1 by m cosine of mx. And because it's a definite integral from 0 to 2 pi, we have taken from 0 to 2 pi. And we can check this, we can differentiate this, and then we pull the m outside, and negative cos, d by dx, negative cos x equals sine x. So then pull the m outside, this cancels out, and you have sine mx, which definitely works. So now we take this from 0 to 2 pi, and that equals negative 1 by n into cosine of m into 2 pi minus cosine of 0. So we ask ourselves what this is. Well, if we draw the graph of the cosine function, looks a little something like that. It's a bad graph, but we'll use it nonetheless. And this is 2 pi. So if we take non-zero integer multiples of 2 pi, we have that cosine of this term evaluates to 1. And we ask ourselves what cosine of 0 is, and cosine of 0 is also 1. So then we have 1 minus 1 equals 0. Negative 1 by m into 0 is equal to 0. This is equal to 0. And therefore our integral equals 0. So we have now proven that the integrals of the sine and the cosine function of a non-zero integer m multiplied by x dx from 0 to 2 pi is equal to 0. And this will aid us greatly in our understanding of the Fourier series. Thank you very much.